Okay, so question 10 of the exam is the last question referring to the jumping antelope, which I'll put back down here. So this question here about this jumping antelope jumping at 8.3 meters per second at 55 degrees. We've already figured out its initial y velocity. At 6.8 meters per second, we know its maximum height is 2.4. The last part of this context is figuring out how far does the antelope jump in the horizontal direction. So we're trying to determine delta x. So delta x will be equal to Vx delta t. Vx is constant for a projectile, assuming no air resistance, so that's going to be Vi cosine of the angle times delta t. So we know the angle is 55 degrees. We know the initial speed is 8.3, so the delta t is is the unknown that we do not know, that we have to determine. But we can solve that considering the motion in the y direction. So we know that delta y is equal to Viy delta t minus 1/2 g delta t squared, but for something that lands at the same height as it launches from, the delta y is 0. For something that jumps from a horizontal surface back to the same horizontal surface, this is equal to 0. So I can state that Viy delta t is equal to 1/2 g delta t squared. So the delta t on the left hand side will cancel out with the square term on the right. So I can state that the delta t is equal to 2 times Viy divided by g. And then what we can do is substitute that back into this expression up here, and then we have all the known quantities. So delta x is equal to Vi cosine of theta times 2 times Viy and divided by g. And if you look up the range formula online, this is technically the range formula that we can actually solve for. But since we have the known quantities, we can go ahead and plug and chug. But just to note, the delta x, this equation simplifies. Just for maybe an additional note, I'll note it down here, and I'll finish off the question. In general, the delta x for something that lands at the same height that it's launched from, this equation simplifies to Vi squared, the sine of 2 theta, the launch angle, divided by g. And this sine 2 theta comes from a trig identity when you expand Viy to Vi times the sine of theta. So 2 cos theta sine theta is equal to sine 2 theta, but again, not completely necessary for this problem, since we have the other quantities. So the delta x here will be the Vi, which we know to be 8.3 meters per second, times the cosine of 55 degrees, and times 2. We know from the question 8 that the y velocity is 6.8. And if we divide that by 9.8 meters per second, the delta x works out to be 6.6 meters. And that gives us choice A.